Hello friends, in my previous video I have already discussed the intuition of covariance and we have came up with the particular formula where covariance equal to summation over x minus x bar into y minus y bar whole by n. This is for population dataset, and if it is sample dataset then this n will be replaced by n minus 1. Alright, now there are two major problems with this particular covariance. So why we use covariance? Covariance is used to predict whether one particular variable is related with other variable or not. Like with increment in one particular variable, whether other variable also increases or there is reverse relationship in between two variables. That idea we can get from covariance. Now suppose you increase all the values of a particular variable by a factor 2, and same for other variable also, you increment all the values of other variable also by a factor of 2. What will happen to the covariance result? Covariance result will be basically 4 times. Why? Because you can simply understand from the formula itself, all the data points of x is incremented by 2, so x bar, that is mean, will be also incremented by a factor of 2. So we can take common 2 in this particular expression, and same goes for y minus y bar. So 2 and 2 will come up as common. 2 multiplied by 2 will be 4. So our new covariance after multiplying all the variables of both the data set multiplied by 2 will be basically 4 times of our previous covariance, right? But this should not happen. Like whenever covariance is giving us the idea how one particular variable is dependent with respect to other variable, then whatever the scale factor may be, we should get the same idea that okay, this particular variable is related to this particular variable by this much amount. Whenever we are doing scaling, it is increasing. If it is more than 1, it is increasing. If it is less, if the scale factor is less than 1, it is decreasing. Covariance is decreasing. Now this should not happen. So the scientists came up with one more general idea, that is correlation. The formula is quite simple. What we do, we take covariance of xy, then we divide that by standard deviation of x multiplied by standard deviation of y. As a result, what is happening? You can see if you expand this particular equation, in the numerator you will be getting summation over x minus x bar into y minus y bar, and in the denominator you will be getting root over of x minus x bar whole square into root over of y minus y bar whole square. Here actually in the numerator by n minus 1 will be there due to formula of covariance, and in the standard deviation also by n minus 1 and by n minus 1 will be there, but n minus 1 in the denominator and the n minus 1 present in the numerator will cancel each other, right? Because the 2 n minus 1 in the denominator will be basically inside the root over. So root over of n minus 1 into root over of n minus 1 will be n minus 1, and 1 n minus 1 is present in the numerator, both will cancel each other. Now you can clearly see, if we multiply all the values of a particular x variable by 2, what will happen? See, very simple. Suppose here all the variables will be 2 times, mean will also be 2 times, all the variables of y will be 2 times, mean will also be 2 times. Same will be reflected here also. This will be 2 times, this will be 2 times, this will be 2 times, this will be 2 times. Now in the numerator what will happen? This 2 will come outside, and from y minus y bar also 2 will come outside. So as a result, total outside it will be 4. So just let me remove this 2. Okay, and now you just observe in the denominator what will happen. These 2 and 2 come outside, but here square is there, so it will come as 4. Okay, 4 will appear here, and similarly 4 will appear here. Okay, so we can remove this 2, this 2, this 2 and this 2. Now what will happen? This 4, when it will come outside of the root over, it will be 2, and when this 4, sorry, actually this 4 will be here. So sorry for this mistake. Whenever this 4 will come outside of the root over, here we will be getting 2, right? So basically this 2 and this 2 now will become 4. Okay, so as a result here we will be getting 4. All right, now as a result what will happen? Eventually this 4 and this 4 will cancel each other. So see, after scaling also, this particular variable is remaining in the same, that is summation over x minus x bar into y minus y bar by root over of summation of x minus x bar whole square into root over of y minus y bar whole square. So this is more general. Okay, this is giving us more clear idea, because after multiplying by a same scale factor in both the variables, it is not changing. Moreover, one more thing happening in the covariance of xy, we are having one particular unit, because you can see in the expression n is unitless, it is a number, and in the numerator we will be getting one unit which is multiplication of unit of variable x and y. But here what will happen? See, very simple. Sigma x and sigma y, that is standard deviation of a particular variable, is having the unit same as the variable. So sigma is having the variable of x, sigma y is having variable of y. So sigma x into sigma y will be having the variable, the unit of x multiplied by unit of y. Same goes for numerator. The covariance is having unit of x multiplied by unit of y. So as a result, the units will be cancel each other in the numerator and denominator, and as a result, the r will be overall unit place. This will be one more advantage. Right? So this is why we prefer correlation instead of covariance. Okay, because after multiplying all the data sets of two variables by the same factor, also the correlation coefficient will be remain unchanged, whereas covariance will be changed. Okay, let me show you one simple simulation. The same code of correlation and covariance I have taken, as I have shown you in my earlier video. The link of my previous video where I have shown you the code, I will post in the description box. If you want, you can check there. What I have done, I have taken x variable one data set and y variable as one data set. Okay, now I am calculating the correlation and covariance as cova1 and cor1. Now in the next scenario, I am taking same x variable, but now I have multiplied by 2, that is scale factor is 2, and same goes for y variable. I have taken same y variable as earlier but multiplied by 2, and I am calculating over 2 for 2. Okay, now what I will do, I will just simply run this particular code and see cova1, I am getting 95.6. okay, so basically covariance is 95.6, which clearly indicates that x and y are positively dependent, that like with increase in x, y increases, with decrease in x, y decreases. Now if I check cova2, after scaling by a factor of 2, we will be getting 4 times of cova1. So although we are just simply scaling, nothing changed, we should get the same relationship. We are getting that, that is positive covariance means with increase in x, y increases, with decrease in x, y decreases, but some other value of covariance. So it is not generalized. But if we check cor1, we will be getting 0.5298. Similarly, cor2 also will be getting 0.5298. So as a result, what we can see, that correlation is giving us same value, and correlation is always ranging from -1 to 1, and it gives, whenever it is positive, that means it indicates that they are positively correlated, that is with increase in a particular variable, other variable will also increase, with decrease in particular variable, other variable will decrease, and if it is negative, that means the two variables having reverse relationship. And if the correlation reaches near to 1, that means they are 1 or -1, that means the two variables are more correlated. Okay, so 0.5298, that means it clearly indicates as the correlation is positive, so that means with increase in x, y will increase, with decrease in x, y will decrease. Okay, so this is what is the idea of correlation, why covariance is not a sufficient tool to get the idea of relationship of two variables. That's what I want to show you using one demonstration. The same code I am going to post in the description box. If you want, you can check there and simulate and feel the idea. Okay, this is all for this video. Thank you for watching.